Okay, in this video we're going to go over the rules of derivatives that we know thus far, and we're going to add two new rules as well. So looking over the rules we know thus far, the constant rule, for example, can be expressed as follows. If you have a function, f of x, and if that function, say, equals 7, then f prime of x will equal 0. Okay, that's true even if the function equals something like pi or e, because they are certainly just plain old numbers. Okay, just to refresh on the power rule, if we have f of x equals 3x to the 7th, then f pi of x will equal 21x to the 6th. So you use the power rule when it's just your x is a plain old x, nothing fancy, it's not a function itself. So that's just a straight up power rule. When the chain rule gets involved, you have this kind of scenario. So what if f of x equaled, let's see, how about 2 times 3x plus 7 to the 4th. So that derivative would be f prime of x equals, and I'm going to probably use a lot of space here, the 4 comes down to the 2 and makes that an 8. So I have 8 times 3x plus 7 to the 3rd, but then I have to tell myself I'm going to take the derivative with respect to x of what's inside. That derivative will be 3. So since this derivative is just a plain old 3, what's going to happen is this 8 is going to turn into a 24 instead. And so under here I'll try to write f prime of x in this situation. I can't get my prime, there it is, of x is going to equal 3 times 8 makes it 24. And then I have 3x plus 7 to the 3rd power, and I'm done. Okay, I wanted to write out some trig rules, so let's think about those. So what if I have, and maybe I'll change colors, and if I say, I'm just going to use this space, I'm going to make this a little bit bigger. Okay, what if I say that f of x equals sine of 7x. Okay, so my angle is 7x. So I would have to then say f prime of x equaled the derivative of sine of x is cosine x. So it would be cosine x, but the x is not just a plain old x, it's a 7x. And for that reason, I'm going to have to go and take the derivative of the 7x. Okay, this derivative right here is going to be 7. So the final result is that f prime of x equals 7 cosine 7x. Okay, we're going to do a couple more of these, so I'm going to stop the video and give myself some more room. Okay, so let's give ourselves some more trig functions. So what if f of x equaled cosine of 2x squared? Oops. Well, let me see if I can figure this out. Hang on one sec. Alright, so that derivative is going to be f prime of x equals, the derivative of cosine is negative sine, never change your angles, and then take the derivative with respect to x of your angle. Okay, that derivative will end up being what, 4x? 4x is going to go in front. Your derivative equals negative 4x, and then sine 2x squared. Okay, let's try some reciprocal trig functions on the next slide. So what if we say y equals cosecant of, I did it again, of 2x. The first thing I would do is rewrite cosecant as 1 over sine. So therefore this can be sine to the negative 1 power 2x. And now take your derivative. Using the power rule, negative 1 sine negative 2 of 2x. Now take the derivative with respect to x of sine 2x, and then take the derivative with respect to x of 2x. Okay, when we do that, we have the following. This derivative right here is going to end up being cosine 2x, and this derivative right here will be 2. So therefore, when you pull everything together, y prime equals, okay, let's put the 2 in front with the negative 1, so that makes it negative 2. And I'm going to do cosine 2x, and I'm going to go ahead and put sine squared 2x in the bottom. Alright, so that's a nice answer. Alright, so we're going to introduce the new rule. There are certainly a lot more trig we can practice, but that just gives you a little reminder of what we've done so far. So let's go to the next page, the bottom of that page of those notes, and we'll talk about the product rule and the quotient rule. Okay, here's our first new rule. It's called the product rule. So the product rule happens when your function is the product of two functions. Okay, so you can say that 3x plus 2 is a function and 6x minus 5 is a function. So to get the derivative, what you're going to do is you're going to say take the left function and multiply it times the derivative of the right function. Then you're going to add the right function times the derivative of the left function. Okay, it's abbreviated as left d right plus right d left, and that's the order we're always going to do it in. So let's try it given that our function is f of x. So f prime of x equals left, just write down the left function, and it is in parentheses. You can tell yourself to take the derivative of the right function, okay, plus right. So here's the right function, 6x minus 5, and then tell yourself to take the derivative of the left, 3x plus 2. So what have I done? I've done the following. I've done right d left plus left d right. Okay, so let's figure out what we get. F prime of x equals, alright, what is this derivative? That's probably just a 6 because the function is 6x minus 5. So let's put the 6 out front, and we have 3x plus 2. Plus, what is the back derivative? That's 3. So we'll put the 3 out front, and we'll do 6x minus 5 in the back. And that's your final answer. Okay, so left d right plus right d left. Let's try one more, and let's do maybe some trig functions with it. So what if my g of x, well, maybe we'll mix it up. Let's have this be sine (3x), so that's the first term, and the second term can be 7x plus 2. Okay, so g prime of x equals left. So d right, and what's that derivative? It's just 7, plus right d left. See if you can do it. What's your derivative of the left function? You've got to do the chain rule. So it's going to end up being a 3. And then what is the derivative of sine 3x? It would be cosine 3x. So I just took a shortcut. See if you can do that yet. So we're going to rewrite it, make it a little bit neater. Bring the 7 in front of the sine 3x. And then plus, we have a 3, we have a cosine 3x, and now you're going to need parens. 7x plus 2, and there you have it. Okay, so what did we do to get the derivative? We said left times the derivative of the right plus the right times the derivative of the left. And that's our new rule. And you'll have ample time to practice. Okay, let's go through a second rule on the next page. Okay, here's another rule, and it's called the quotient rule. So if you have a quotient and you want to take a derivative of it, you would use the quotient rule. So this is how we say it. It is low d high minus high d low over low squared. So that's the rule. Let's try to apply it in this g of x example. So we have g prime of x would equal low. What's your low function? That would be the 2x minus 8. D high, what's the derivative of your high function? That would be 7. Minus high, which is 7x plus 4, times the derivative of the low, which is 2. And then don't forget, it's all over low squared. Okay, so we would clean this up a little bit. G prime x would equal 7 times 2x minus 8 minus, put your 2 in front, 7x plus 4 over 2x minus 8 squared. Okay, sorry about that sneeze, but that's what I have for my final answer. Let's see if we can do one more on the next page. So let's make up a function. What if we said that f of x equaled tan 3x over, let's do x, we'll do 3x plus 7 squared. Okay, so we've got a little complications going on here. So f prime of x is going to be low. Write exactly what you see. D high. Okay, so we have to remember that's going to be the derivative of tan is secant, and I'm going to have the chain rule, so I should be getting 3 secant squared 3x minus, so I did low d high minus high d low, so I'm going to have tan 3x, and then I'm going to try to squeeze this down here, times, well, let's see what I'm going to do. I'm going to have the chain rule, I'm going to have the power rule. So I'm going to end up with 6 times 3x plus 7. So see if you're getting what I'm getting. I brought the 2 down, and then eventually I brought the 3 out to multiply by it. And then all of this is over 3x plus 7 squared. Okay, so we're going to clean it up. F prime of x equals, I have a 3 secant squared 3x And then I have a 3x plus 7 squared minus 6 times 3x plus 7 times tan 3x all over 3x plus 7 squared. Now, notice that you can reduce this a little bit because the rule of 3, I have 3x plus 7, 3 places. 1, 2, 3. So what can I do there? So let's try to do this in the next page, and I want to practice reducing this. Okay, so here's our answer. Let's factor out a 3x plus 7 from the top and the bottom. So that's going to give me, this is still going to be, whoops, f prime. Let me just change my color so you can see. So that'll still give me f prime of x equals. So I said I'm going to factor out a 3x plus 7, because that's the highest power that they all have in common, from the top and the bottom. I'm going to do it this way because this is the safest way. When I do that from the top, what do I end up getting? Well, I'm going to get, I still have a 3 secant squared 3x times a 3x plus 7, because I still have one of them left. And then this is going to be minus 6 tan 3x. Put that in the box. And then all over, I have one more of these guys left. Okay, now, what's nice about this is that 3x plus 7 over 3x plus 7 is just a 1, so that can go. So my final answer will be, so I'm going to bring that 3x plus 7 up in the front. I think it looks better up in the front. And this is secant squared 3x minus 6 tan 3x all over, whoop, I wanted to only have this 3x plus 7 to the first power. So let me erase that. There you go. That works. So that is a good final answer. Okay, at this point what you need to do is go through the packet and see if you can do that work. I have included an answer key for every page I'm giving you. Now, what would not be wise would be just to copy down the answers. That's very unwise. What is equally unwise is to never look at the answers, because if you do that, you might teach yourself how to do it wrong. So I'd like you to look at the answers as you go and go and do that whole packet. Okay, whatever's not done today will be due for homework.